Welcome friends. Today let us learn about data coding. But before we actually enter into the world of data coding, let us learn something about measurement, scales and scaling techniques. Well, then we go forward. What is measurement? First thing is that when we want to measure something, we just can't measure that particular object, but we measure some characteristics of that particular object. Suppose I want to measure a human being. Now, we cannot measure a human being. We may measure his height, we may measure his weight, we may measure how sincere he is, we may measure about his honesty by putting him into some situation. Honesty, sincerity, this cannot be directly measured, but we can find ways and means when we can measure all these things. All these are different characteristics of the individual. So the individual cannot be measured. Rather, the characteristic of the individual can be measured. Take an example of, we have an example of a Pepsodent, that is a toothpaste. It's quite common ad coming in the television these days, and we see that there are two schoolboys. They are sitting in the last bench of a school bus, and one of the students is quite depressed. The other student is asking him, "Why are you so sad today?" He told that no, that today in the class there was a dental checkup, and I failed that particular checkup. Listening to this story, his friend is telling that you have not failed, but your toothpaste has failed today. That means the individual cannot be measured, but some characteristics of that individual is measured. It is very nicely exemplified in that particular ad, and so I have picked it up to explain to you in the class. So what is actually measurement? We are thinking of bringing about a one-to-one correspondence between the characteristics to be measured. And suppose their characteristic is height. So what happens, we bring a one to, suppose this is an individual, I want to measure his height. So this is his height. Corresponding to this height, I am thinking of a number. That means I am attaching this height to a number, say 6 feet. That means you see the characteristic height is now converted into a number. This process of connecting a characteristic to a number being measured is called as this technique is called as measurement. Scaling technique is an extension of measurement. Here a continuum is created to which you can locate these numbers. Generally, if you listen to the word scale, you think of a foot rule. So a foot rule looks like this. Say, let us have a fresh view of that. Okay, let us have a foot rule here. Suppose this is a foot rule. So I have this a foot rule like this. Now anything which is happening, and the foot rule starts with a 0 from here, and maybe it goes up to 12 inches. So in between there are some marks which are, for example, 6 will be just in the middle. So there are some marks in between. 3 will be the middle of this, and here you will get exactly in the middle of that you will get 9. So these are the values. Now this continuum is created over which the object that is to be measured is located. This one-to-one correspondence is created by this continuum, and this continuum is called as the scale. This continuum is the scale. So this is quite commonly used in marketing research. We think about different types of scales, which is not like the foot rule, but rather it is a computational scale which is based on the attitude of the individual towards different statements. Anyways, we'll have this discussion further when we go to scaling techniques. There is another video on scaling techniques. You might have a look at it. Now let us look at the different scales of measurement. First we have the nominal scale. A nominal scale is we are assigning numbers to some. For example, suppose you ask that what is the gender of a group of individuals. Everyone is asking. Everyone you are asking what is the gender. Now this gender of an individual will be male, will be female, and will be say transgender. Now problem is an individual will be either a male. This individual will either he will be a male or a female, or he will be he or she will be a transgender. Now, there is no possibility that simultaneously you will be a transgender as well as female. That means he is mutually exclusive to fall in any one of these groups. And and all your individuals that you are going to study in will fall in any one of these categories. That is, they are jointly exhaustive, mutually exclusive, and collectively they are exhaustive. So that is an aspect. Now what we do is that we assign some numbers. Say I give 1 to male, I give a number 2 to female, and I give a number 3 to transgender. This does not make transgender better than the male or the female, or the number 1 does not make the male better than the female or the transgender. These are some simple tags which are associated by numbers and collected to these different categories. So this is called as the transgender. So religion may be numbered. For example, I may put number 1 for Islamism, I may put number 2 for Hinduism, and I may put number 3 for Jainism, 4 for Buddhism. Now here these numbers does not have significance in terms of their values. Obviously they have significance in terms of identification to that particular religion. The class numbered higher is no way inferior than the one numbered lower or the other way. And these classes are mutually exclusive and collectively exhaustive. And sometimes alphabets as well as symbols may also be assigned. We go to the next one, that is the ordinal scale of measurement. Ordinal scale of measurement, same as in the previous case, that is individual is divided into several groups. Means you will fall to any one of the groups into which the classification is done. This classification process is mutually exclusive, collectively exhaustive. This much is fine. Next point is that now the classification has some order. There is an order in which you can place them. For example, suppose educational qualification. I tell that okay, less than 10 years of formal education. Then 10, that is the metric, which you call as metric. Then 10 plus 2, which is the intermediate level. Then comes graduation, and then comes post graduation. So now this I can give a code. This is 1, this is code 2, this is code 3, this is code 4, this is code 5. Now these are all highest qualification. Suppose my highest qualification is post graduate, that means I will be here. Someone else highest qualification is say could not pass the metric examination, that is less than 10, so he will be at this position. So this way people will be classified in any one of the groups. So they are, and one person cannot be in more than one group simultaneously. So mutually exclusive, collectively exhaustive. This issue will always be there. Now what is the problem is that here, but there is an order, not like the other one that we cannot put them in some order. Like giving a code 1 to Hinduism does not make Hindus more important than the Islam, so who are having suppose a code of 3. That thing is not happening here. Here there is an order. 5 is the best one in terms of highest qualification, then 4, then 3, after then 2, and then 1. This is called as ordinal data. Also, you can sometimes think of ranked data. That means I have 5 individuals. Individual number 1, say his name is A. Individual number 2, name is B. Individual number C, people as C. So this one is of rank say 2. This one is rank 1. This one is having a rank 3. So he is the best one, having a rank B. And then we have rank A, and then we have a rank. This is the order in which the ranks goes on. So this is ranking is an example of an ordinal scale. We go forward. Next one, we have the interval scale. In interval scale, there is a way in which we can measure things numerically. Earlier we can put them in order, but we don't know by how much one is better than the other. Here we have an ordinal. Here we have some numerical scales to which. But the problem is, for example, suppose your experience in our hotel is. I ask you this question: your experience in my class is, say, in my class, or about my class, about my class is. Now good, bad. If it is good, you tick here. If you think that no, not so good, but it's in the good side, you may tick here. Someone may tick that no, not that good nor bad, he may tick here. Someone else, let me change the color. Okay, someone else may find that it's rather bad. Someone may find that it's not at all, no use at all, may tick here also. So This let me color differently so that I can mean that it is a different person giving the tick. And so this one let me take black. Now this is a way in which you can give. Suppose you are this red person, so you are telling that I am good, yeah, quite good, not pura good, but okay, it's okay, fine. So this way you have can tick. Now this is a number. You see, this is in order. You know, if I tell bad by how much is the difference between the two, that we can find out. You can reverse the scale also. That is the one flexibility of the scale, but that is one disadvantage also. That instead of coding it this way, someone else may code it is in this way: 5, 4, 3, 2, 1. So when you do some calculations based on such type of scales, they might not give you unique results. It will depend on the way in which these are placed. Someone may code, okay, this is -2, this is -1, this is 0, this is 1, this is 2. So this is a way in thing can be coded. Now we come to ratio scale. Ratio scale is the superior of the scales. It is quite, in some way, it is similar to the interval scale that you have studied. But the thing is that it is superior in the sense that there is an universally accepted zero in the scale. For example, earlier I gave the example of a foot rule. Now foot rule is something like this. Now what happens in foot rule? There is a scale, there is a universal 0 here, and there is 12 at the end of the scale. So there is a universal starting point which everyone will accept. So you know where to start, where to end, and so measurement of this characteristic will have an universal appeal. And suppose the ratio, for example, suppose this length, same length, this one I am placing here, I am placing it like this, and this one I am placing here, placing is like this. They will have equal distance from here to here in this scale. So this type of flexibility is there in the ratio scale, and since it is having an universal 0, so it is accepted everyone will get the same measurement, which is not the case in case of interval scale. For example, interval scale, in the same scale, you may use a code of this type of code. You may use this type of code, but I may use the other type of code. Say I may use this type of code. So if you tick 5, then it is bad. But if I take tick 5, it is the best option possible. So your 5 and my 5 may not have the same meaning. Such cases does not happen in case of ratio scales. So ratio scale is free from all these things. Okay, if we go forward, then we take an example where we can set everything. Like if I ask you which is the drink you like most or not like most, I tell you that name some cold drinks which you prefer. So you are just telling some cold drinks which you prefer without maintaining the order of preference. So this is an example where actually you have some nominals. This is called as nominal scale. Then we have ordinal scale. In ordinal scale, we can put things in some order, like Coke, Pepsi, Mountain Dew, 7-Up, Sprite, Thumbs Up. So these you are asked to place in order. That means you are to rank them. For example, suppose I may give a rank like this. Say I give a rank here. I may give rank here 1. This one I give rank 2. This one I give 3. This one I give 4. This one I give 5. This one I give 6. That means you understand which one you prefer. Also you understand the order of my preference. Okay. Now here we go one step further, that I understand your order of preference by how much I prefer. For example, suppose I give never. This one also never. This one I give rarely. This one I click on sometimes. This one I click mostly. This one I click always. So you understand that I prefer this one to Sprite. I prefer thumbs up to Sprite. I also prefer thumbs up to 7-Up. But my preference is more close to Sprite than to thumbs up, than to 7-Up, given its thumbs up. So this way you can also differentiate between that. And this is quite typical in the sense that I have total 100 points. Now 100 points I am to distribute among this. For example, suppose this one I give 35, this one I give 30, this one I give 15, so this one I give 20, this one I give 0, this one I give 0. So is it 100? This is 35, 50, yeah. is 100. So this is total 100. This is how I distribute. So this way you understand how much I prefer Coke over Pepsi. What is the amount of difference that also you can make. And Dew is, you see, Pepsi is almost twice favorite to me than Dew, because Dew is 15, Pepsi is 30. So that way you can make all possible computations, and that is an example of an interval scale. Sorry, ratio scale. It's the highest of all this. Now comes data coding. The process of converting answers to questions in a survey into numerical is called as data coding, or simply coding. That means the answers are to be converted into some numericals. Why? Because data coding is an integral part of modern day questionnaire. In modern day questionnaire, mostly you will come across closed-ended question. That means question will be there and all the options will be below this. And some people are little bit relaxed or little bit flexible, in the sense that they put one code which is others please specify. That means you have some other option, then you can specify that option. You have a option of specifying this. Data coding is an integral part of modern day questionnaire, and so all questionnaires these days have this facility. It facilitates entry of data into computer for further analysis. It makes things easy. Entry into the computer becomes easy. If I have different options, each option will be coded. This code will help me to enter the data in a much better way. Coding is generally related to categorical data. Now let us look at the necessary steps of data coding. First, let us look at classification of responses. There is no objective way of classifying the responses. These are created by the researcher based on generally a cultural or a historical setup. Cultural setup means, suppose I have gone to survey in a particular place, there are some cultural norms in that particular place. So some of the options there might not be valid, which are quite common in another location, in another place, or maybe in the same place 20 years earlier. Things keeps on changing along with things that along with the fast changing world. The environment changes, the behavior of the changes, the customs and tradition of the people changes. So sometimes which was quite, say, 20 years earlier, something which was a very possible answer might not be a answer at all at the current state. So based on this, and historically means people have performed survey on that area, on that particular topic in a given region. In that particular region, those topics might be the may not be the same now. So, but even then, I am using it because previous researchers have used those options. Then, in case of survey, when you conduct the survey, if necessary, there are ways and means through which you can change the codes. But generally, I tried with an historical setup because several researchers working in this field has worked in the similar lines or given code. This we have already explained. With time and space, things changes. Our decision is taken about the classes. They need to be coded generally with integral values. So we may divide the answers into some classes, and then what are the codes of these classes? Generally, integral numbers are used. Generally, it starts with 0 or it starts with 1, depending on the purpose. Sometimes it is pre-coding, sometimes it is post-coding. In pre-coding, before we conduct the survey, when we make the questionnaire, we do the coding. This is called as pre-coding. In post-coding, after the survey is over, when you have exposure to all the different options, then we do some type of coding. This is called as the post-coding. Post-coding is quite common in exploratory research or in pilot surveys. When you actually, basic purpose of your survey is to explore, you don't know the answer to many questions, you don't have idea about what may be the options of a particular question. In that case, we can keep initially open-ended question and note down what is the responses. Once we come back and design our main questionnaire, we may classify those responses into some heads, and each head may be coded. So that is a process of post-coding. Post-coding is quite popular in case of pilot surveys and in case of surveys which are not which are rather exploratory in nature. So we go here. Let us look at the next one, allocation of codes. For allocating codes, there should be at least two categories to a particular question. The essence is to get distinctive code to each category of the variable. Means code should be distinct. For example, if you are classifying religion, you identify the religion. Each religion will have a particular number to represent it as its code, and that number should be unique. That means that number should be the only number connected to this religion. To some other religion, the number will be different. That means they should be unique. Partial coding can be done in case of all options are not anticipated at the beginning of the survey. So this is quite common in pilot surveys or in exploratory research. The anticipation can be substantiated by a pilot survey. Allocation of codes continued. The codes shall be flexible so that further categories or codes may be added. So it should have an option of including more codes if necessary at a later stage. So obviously integers, there is no end of integers, so you can do it. Sometimes some questions might have multiple responses. For example, how do you come to know about our company? You can know about our company from newspaper, you can know about our company from roadside hoardings, you can know about our company from television ad. So all these options come, and you may have multiple. Yes, that means not classified as a mutually exclusive. You can be in multiple groups. In that case, such responses are called as multiple responses. In multiple responses, you give all the options, and corresponding to each option, you give the code yes and no. That means if that is done, then yes, otherwise no. In this way, we can have the multiple responses. And numerical coding, numerical things like age, like income, like salary, these things can be coded numerically also by, say, I age example, below 10 code is 1, 10 to 20 code is 2, 20 to say 35 code is 3, 35 to 50 code is 4. This way you can do, but this way if you do, then it takes to lack of information, loss of information, sorry, loss of information gets lost. Instead of taking the actual value, you are using some codes which are less informative. So that is called as the way in which numerical data can be coded. Now code for missing responses. Now sometimes responses go missing, but there are different reasons for which responses might go missing. One of them may be the respondent is not required to answer. So respondent is having an answer, but he is not required to answer because he does not fall in that category. For example, answer the following questions if you are staying in rented house. Now I stay in my own house, so I don't have any answer. So in that case, suppose I use a code. Say for this case, I use a code. This type of missing responses, I use a code say 9. So if the code is this way, this type, then I use a code 9. Now either responses or interviewer has missed. That means the answer is might be known to both the respondent, but the interviewer or the respondent due to some reason is unable to answer, means they just ignored it out of mistake. Give it a code say 99, so that I know that if I see a code 99, it is missed due to negligence of the respondent or the interviewer. And the respondent refuses to answer. Now this is a typical type of thing where respondent, I give it a code 999. That means the respondent is telling that no, I will not answer. So this respondent has no option and don't know the answer. Respondent does not know the answer. So what happens? No opinion. So I may give it a 4999. So this type of different missing codes for missing responses can be used. Now entering the data. Now when we enter the data in the computer, they are done in the form of rows and columns. Along the rows are the observations, along the column are the variables. And variables are taken across the column, cases are taken across the row. I have an example here. Suppose this is I am collecting a data. So in this data, I am the name of the individual. I have some options. Like the name of the individual is Jalil, and this person whose name is Jalil, he has a So his name is Jalil Ahmed. Okay, fine. Now he is having male. So this one, he is staying in rural area. This has happened due to mistake. So we may check it out that which one is correct. Sometimes confusion arises, and then we found that no, he resides in a rural area. Semi-urban might have gone there by mistake. So drinking water is availability of drinking water option is very near to the premises, and source of drinking water he is using tube well water. Now when I uh, and come out of my questionnaire and enter the data in the computer, it will be like this. This side I will pull all serial number, all the variables. That is serial number, date, gender, mobile number, place of residence, source of drinking water. This one available in the premises and the source of drinking water. These are the name of the variables. Corresponding entry, that is serial number is 33, so we replace here 33. Date of collection, this one we replace. So we write the codes, as you can see, 1, 2, 4, like this we put the codes. We don't put the verbal descriptor along accompanying the code, but we actually put the code. This helps us in data analysis, it will help us. So this way, now suppose another person data I collect, I will replace that person's data here along this. So this is number, serial number is say 31. So 31, date of collection is say 14 6, same date 201. Suppose that person is female, so instead of writing a female, I will write the code, that is code is 2. So like this we will fill it up. So as the number of observations keeps on increasing, more and more rows will get populated. Okay, so that is the status over here. And then lastly we want to check the error codes. For that we go to the last option for checking of error codes. So you have this, so valid range check. That means suppose I have a question, suppose this question, do you purchase ticket online? You see codes are 1 and 2, 1 and 2. These are the two codes 1 and 2. So when in this particular check question, that ticket purchased online, below that the options, you will not get any option like say, so tickets online. Suppose this is a variable. Below this, first person is telling yes 1, second person is telling no 0, third person is telling yes, fourth person is telling yes. So like this it goes up. Now here fifth person is telling, if I write 2, then you understand that this is a out of range code. A valid range check fails. Valid range check fails for this. That means here some mistake is committed. We require to check it up. So that is the thing happening here. Okay. Another interesting thing is that, let me erase some of these marks. Now look at this. Did you purchase online ticket? Filtering, checking from other variables. That means I check the value of a variable which is connected to some other variable. Like here you see, did you purchase the ticket online? Yes. If the answer to this question is yes, then and only then this question becomes valid. Which network did you use for purchasing the ticket online? So there are different networks. Now if the question to this is no, not yes, but no, then the question of this particular query does not come at all, because you have not purchased. Then what is the point of asking which network you use? So sometimes some errors takes place like this, where questions which are connected to each other calls for some poor responses. Okay, we have this. Now look at this logical check. Here you see you get a response, but your response is connected to some other response. For example, there are two variables. One is age of marriage. So you are asking the age of marriage of couples. Okay, and you are asking the age of their eldest children. Now this seems to be a little bit absurd. The age of marriage is 20 years, but the age of the eldest child is 22 years. This looks absurd. This does not set in an Indian setting. This generally doesn't have take place, but it may happen like if the child is a say stepchild. That means this is married for 20 years. Current marriage is for 20 years, but he had a child before, or child before his marriage from some other spouse. So that way, this might be correct also, but this requires checking. It may not be bluntly wrong, but requires some checking. So these are checking code for errors. In conclusion, we would like to tell that coding is a very important aspect of modern day questionnaire, as every time we are actually entering the data from the questionnaire to a software, and software generally prefer to have numericals than verbal descriptors. So these most data entries are done in software, and all categorical variables need to be coded for that. It is easier to detect error pertaining to errors in coded data than those which are used in uncoded data using software. Thanks for your patient hearing. All the best for your all data coding works. Thank you for watching this video.